All right. Well, we've had a packed day. I mean, is it just me or is the time flying by? I feel like maybe it's just me. The rest of you guys are like, this is taking forever. No, it's like, I can't believe this is the last session. Just want to let you guys know, I work for Stand to Reason. They're based in Southern California. I work with, you guys know Alan Schleman, and there's some other speakers as well. I mean, there's a team of about 18 of us. And I want you guys to know that we are, as an organization, we're here for you. If you have challenges, you have questions, check out str.org. I know a bunch of you probably already familiar, but if you're not, this is why we exist. We don't just want to be a ministry that comes in. Part of the problem with this, and my heart's kind of torn on this, I love speaking at events like this, but I kind of just fly in, then I'm gone, you know? Fly in, fly out. And one of the ways that we stay connected with people and disciple kind of from a distance, because we don't want to be just an informational ministry, we want to be incarnational, we want to be helping to form a certain kind of person, ambassador for Christ. One of the ways we do that is by sending you guys material, you know, and that's articles and posts and videos and all that stuff. I mean, literally each week you'd get something in your inbox. If you are interested in that, I would strongly encourage you to pull your phone out, and if you just point the camera at that QR code, what should happen is with your camera, it should put up a link, you click the link, and literally you're just gonna put in your name and email, I think. Not after your money, we literally want your email so we can send you articles that we're writing. I'm telling you, you guys like Alan, I like Alan too. That dude every month has an article, a mentoring letter that is usually on the transgender issue, sexuality, something in that area, usually the most pressing questions and challenges that are coming out in that area. And I make sure I read all his stuff because it helps me. If you've watched Red Pen videos, I'm telling you, when I make a Red Pen video, a lot of people think, oh, I just pull up the video and respond. That's not how it works. I do my homework, and that usually involves going to Stand to Reason. Okay, is there anything on there? Okay, if it's on sexuality, Alan Schleman has written on it, okay? So I'm usually just kind of going, or I pick up the phone and just call him. But typically there's an article that's been written, so that's how they get to you, is through there. So there you go. The other thing that I want to let you guys know about is Elisa Childers. You guys know who Elisa Childers is? I know you do. I already signed your book. That's good. Her and I, a few years ago, it was probably 2.5 years ago, where I was at a camp and I was asked to speak on deconstruction. And I did 5 days. I was the morning Bible study teacher, Monday to Friday, teaching on deconstruction. And actually about midway through, it was like Wednesday, I was thinking a lot about this topic. Just so you know, deconstruction is the idea that it's the hashtag people are using, hashtag deconstruction, to describe their kind of exit from historic Christianity towards something else, whatever that is, progressive Christianity or atheism or whatever. And I noticed that deconstruction is like the vehicle that's getting a lot of people to progressive Christianity. And she wrote a book called Another Gospel, did really well on progressive Christianity, responding to that. So I sent her a text and said, hey, Elisa, like, when are you writing the book on deconstruction? And she said, Tim, I am way too busy. I'm currently working on my second book, and after I'm done this, I don't want to write another book for a while. So then I responded and said, well, this book needs to be written, so do you want to write it together? And she was like, let's talk. So it was kind of like 2 years in the making, putting this thing together, and it's available now. It came out last month, and it's doing pretty good on all the things. So it's on Amazon if you want it. You can get it on there. All right, we're going to end And then I promise some Q&A at the end after this session. But we're going to talk about the heavens declare the glory of God. This is when people ask me, what's the thing you love to talk about? And one of the things I love to talk about is the fine-tuning of the universe. I actually think this is one of the strongest arguments for God's existence, if not the strongest argument for God's existence. Okay, so let me start with a true story that all begins April 11th, 1970 at 2:13 p.m. Eastern Standard Time. Hands up if you know the significance of that date. Anybody? Anyone want to take a guess? You say my birthday? See, now I'm offended. Because I was born in 1983. So we can't talk. No. Someone always says your birthday. So that's it's true. I mean, I look older than I am, unfortunately. No. Good guess. It has to do with astronomy. See, the Star Wars font is meant to throw you off. It's a good guess, though. It's a good guess. Okay, it's actually the launch of the Apollo 13 spacecraft. So 2:13 p.m. Eastern Standard Time, April 11th, 1970, Apollo 13 launches from Kennedy Space Center in Florida. This is the third mission to the moon. Now, unfortunately, as many of you know, Apollo 13 would actually never land on the moon. See, initially everything was going to plan on this magnificently designed spacecraft. However, 55 hours and 54 minutes into the mission, traveling at 2,000 miles per hour, that's as fast as a speeding bullet, the crew feels and hears an explosion. And then you hear pilot Jack Swiggert's famous words, "Houston, we have a problem." And it was a serious problem. The explosion turned out to be the astronauts' worst nightmare. One of their oxygen tanks had exploded, and the other one is leaking into space. Two of the three fuel cells are now dead, and the third is rapidly depleting. The Apollo 13 crew has a new mission, and that is to bring the astronauts home safely. And that they did, okay? Despite limited power, a shortage of cabin heat, they had to create this carbon dioxide removal system. I mean, all these hurdles. They actually returned home April 17th, and this mission was called a successful failure. Now, why am I telling you about this mission? Well, just as the Apollo 13 crew survived against all odds in the lethal conditions of space, we too survive against all odds on this tiny planet that we call Earth. Okay, the conditions of the Apollo 13 spacecraft are finely tuned to support life, the life of the astronauts, and the slightest change in these conditions put the astronauts' lives in danger, in jeopardy. In a similar way, the Earth and what we'll see, the solar system, the galaxy, the universe, are finely tuned to support life. And the slightest change in these conditions actually puts all life in danger. And so scientists say that the fine-tuning is balanced on a razor's edge. And what they mean by that is imagine a tightrope stretched across two skyscrapers. Literally, on either side of the tightrope, the conditions do not support life, right? I mean, you take one step to the left or one step to the right, and you plummet to your death. Only the narrow position on the tightrope actually supports life. Now, what I want to do is show you that there are certain conditions that are finely balanced, finely tuned, just right to support life. And these just right conditions are applied to the Earth, they apply to our solar system, they apply to our galaxy, and most importantly, they apply to the structure of the entire universe. And so what we're going to do in the next 35 minutes is go on a little bit of a journey, okay? From the Earth to the solar system, to the galaxy, through to the universe. How does that sound? Does that sound pretty good? Okay, so buckle up. Here we go. All right. Now, how many of you have heard of Goldilocks and the Three Bears? Okay, we're all good. Goldilocks and the Three Bears. One porridge is too hot, one is too cold, and one is just right. Well, astronomers like to talk about something called the Goldilocks principle, okay? And this is the distance from a planet to its planetary star. Ours is called the sun. And we happen to be in what's called the Goldilocks zone, okay? Now, here we are. So there's our planet there. We're the third rock from the sun. And where we reside is in what we call the Goldilocks zone. Here's what I mean. If we were to go a little bit further away from the Earth, outside of this Goldilocks zone, this life zone, it would be too cold, okay? Now, Mars is a little bit further out. Mars is quite cold. In fact, at its equator, in like the summer, the average temperatures on Mars are like 0 degrees, okay? Average temperatures. If you were to go a little bit closer to the sun, like where Venus is much hotter. Now there's a couple reasons for that. It's has a runaway greenhouse effect because of its gases, but it's around 700 degrees at its surface, okay? So too hot. But Earth is just the right temperature. Now, it's not just about temperature, but it's a temperature to get liquid water. You see, if you're too far out and it's too cold, you're just going to get ice. If you go too close to the sun, it's too hot, you could get water vapor. But what you need for life is liquid water. And if you've been to Earth, which is beautiful this time of year, you get all three states of water. You get solid, liquid, and gas. Now, actually, what you're looking at is really cool. So we're going to do a little detour here. What you're looking at is phenomenal. In fact, it's one of the reasons we have life on this planet. Okay, so our planet is 70% covered in water. That's good. That's good. But water has so many unique properties that allow for life on this planet. One of them is not just the abundant supply, but our Earth has an active water cycle, and it actually moves minerals. So our water is a universal solvent. It can dissolve all kinds of different things, and that allows minerals to actually move throughout the Earth, which is kind of cool. It also has a very high, we call it a high specific heat capacity. What's that? It's like if you've ever been to the beach and the sand is like so hot on your feet, and then you have a little puddle of water and you could put your feet in it and it cools them down. How does that work? Well, it's easier to heat up sand or your driveway or whatever. It's easier for the sun to heat those up. It doesn't take a lot of energy to raise the temperature of sand or the concrete or asphalt or whatever. Water is different. It takes a whole lot of energy to raise the temperature of water, even 1 degree. It has a very high specific heat capacity. And that is also essential if you want, it's just a cool thing about water. But here's the most important thing about water. It's different. Water is different from every other naturally occurring substance on our planet that we know about, in that when it goes from its liquid form to its solid form, does it get more dense or less dense? Liquid to solid. Now, what's interesting is we teach this, and I taught this in science, particle theory. As you go from your liquid to solid state, actually particles get closer together, and so it gets more dense. But because of water's molecular structure, H2O, it actually gets less dense, and it's why that giant ice cube is floating. You see, if water was like every other natural occurring substance, then when it goes to ice, it should sink to the bottom of lakes and oceans and freeze from the bottom up. That would be a huge problem for life. But water isn't like that. Water's different in that it allows marine life to survive because it floats at the top. Now here's just a little experiment you can do at home. Take a glass, fill it with water, and then put some ice cubes in it. And if they don't float, you did something wrong, okay? So there you go. Now, okay, back to what we were talking about. Forget about water for a second. The earth not only is at just the right distance from the sun, the Goldilocks principle, the earth is actually tilted. And you probably noticed as you walked in the room how it was like tilted, right? You felt it? No, you don't feel the tilt. But it's a good thing that it is tilted, because if it wasn't, the radiation from the sun would just cook the equator and freeze the poles, even at more extreme temperatures than they currently have. And we already have some pretty extreme temperatures at the equator and at the poles. But as many of you are aware, Earth is tilted, and it's tilted at 23.5 degrees. And this actually allows for our seasons. Now, there's lots of planets out there that have tilts, but they wobble all over the place, okay? And that's not good if you want a planet with life on it. What's really neat about our planet is that it not only has a tilt, but it has a stable tilt. And what stabilizes the tilt of the Earth is actually our large moon, which we call the moon, okay? Not very creative. Every other moon has like a cool name. Ours is just the moon. It's about a quarter the size of the Earth. And it allows the Earth to stay tilted as it orbits the Earth. Very, very cool. But I can see you guys aren't impressed by that. So say, Tim, I'm not impressed by that. Say, Tim, I'm not impressed by that. Okay, we'll see if we can impress you. Okay, so the magnetic field. You guys know that our Earth has a magnetic field. It's like a giant bar magnet in the center of the Earth. And it's actually a liquid iron core, but it does the same thing. It creates a magnetic field, and which is a really important part of life on our planet, is because this magnetic field actually deflects these particles, these charged particles that are coming from the sun that would obliterate life on our planet, okay? Now, what's really neat about this effect is, as these particles get deflected towards the poles, they interact with the atmosphere at the poles and produce what we call the northern lights. So have you ever seen the aurora borealis or the northern lights? What you're witnessing is basically our protective shield that is allowing for life on our planet. But I can see you guys are not impressed by that. Say, Tim, I'm not impressed by that. All right, let me see what we can do here. Okay, let's go from the Earth to our solar system. Now, our solar system is kind of neat. It's actually unique as far as we can tell. It has these large gas giants kind of outside, where the terrestrial planets are on the inside. We find other stars with planets orbiting, those exosolar planets, and those planets typically are like Jupiter size, and they're really close to the star. Ours are in a very important location, which I'll come to in a second here. Pluto now this is not to scale. Pluto looks humongous. But Pluto, you guys hear what happened to Pluto? Planet anymore. Demoted. Not cool. See, how many of you were in school and there was 9 planets? Those were the good old days, right? Those were the good old days. Well, yeah, there are now 8 planets. Pluto got demoted. Pluto is now referred to as a dwarf planet, okay? Now, it was a discovery made, I think it was the late 90s. A lot of people think, it's because Pluto is too small, and that's why it was demoted. It actually has nothing to do with its size. It has to do with its orbit. If you want to be a planet, you have to have cleared your orbit. So if you share an orbit with another planet, you can't be a planet. I don't know who gets to make that decision. Okay, that's above my pay grade, okay? But so the orbit of Pluto is highly elliptical. This is what was discovered. And since it crossed over Neptune's orbit, it was demoted. Okay, so we got 8 planets, 4 gas giants, and 4 terrestrial planets. Now, I want you to imagine we have an asteroid. And this asteroid looks like it's coming straight for us. So everyone together, oh no, it's an asteroid headed. I felt that. I was a little Armageddon situation here, okay? So here, but we're not actually worried. We're not really worried about this, and there's a reason for that. These guys here act like, now, I just started watching football, and it wasn't because of Taylor Swift, okay? I started getting into football, and I still haven't, I need to pick a team, okay? Do you guys recommend a team? Who's like? The Bears? Packers? Oh, okay, he's got the sweater on. So I don't know who, but I want to start watching football. See, in Canada, we have the CFL, which is not real football, okay? And then we got hockey. Everyone's a hockey fan, But these guys are like the offensive line that protects the quarterback. Their gravitational pull is so strong. In fact, okay, this is not to scale. This is Jupiter. This red spot here is a storm, like a hurricane, that's lasted hundreds of years, and it is like 2 times the size of the Earth, okay? This one storm is 2 times the size of the Earth. You could fit 1,300 Earths inside Jupiter here, okay? The gravitational pull is incredible. In fact, we see as Jupiter orbits, there's all this space debris that kind of follows behind it, okay? Like it's the gravitational attraction is causing that. So we're not worried. So when the asteroid, heads, it's going to get sucked into, the hope at least, and what we've seen is a lot of impacts into Jupiter and some of the other gas giants. In fact, I think we see about every month a good-sized impact on Jupiter, which is kind of wild. An impact that would obliterate life on this planet, okay? So literally, we should thank God for Jupiter. When I was teaching the public school system, I was using the public school textbook, and there was this astronomy unit to deal, and it was specifically the solar system. It talked about Jupiter, and it actually said this: Jupiter is a cosmic vacuum cleaner. If Jupiter didn't exist, you wouldn't either. And it's true. Jupiter didn't exist, you wouldn't either. In fact, my daughter, one of my daughters, when she's 12 now, but when she was 4 or 5, she heard me talk about Jupiter, and for a year, in every one of her nighttime prayers, she would thank God for Jupiter. It was adorable. It was adorable. So thank God for Jupiter. Okay, let's go from there. Say, Tim, I'm not impressed by that. You liars. Okay, so the galaxy. So we got a cool solar system. I think a solar system that is uniquely designed for life. We also have this really cool galaxy. Our galaxy is called the Milky Way galaxy. It's a spiral galaxy because it has these spiral arms. Now, the arms are just made of dense clusters of stars and dust and gas. In the center, we think there's a black hole. A black hole is just a massive body that is so massive that the gravity of it actually won't allow light to escape. And so it appears black when we look out in the night sky, but to our telescope, but we see things orbiting around it. And so they've called this thing a black hole, okay? Now, where we reside, now this is not our particular galaxy, we're in ours, and so it's hard to take a picture of your own galaxy, but we think this is what our galaxy looks like and where we reside in it. This is around 100,000 light years across. If you're gonna measure something humongous, you need a big yardstick, okay? And so the yardstick they use is a light year. And that is the distance that light can travel, or light travels in 1 year, which is 6 trillion miles. That's 1 light year. So we got 100,000 light years across. We think there's around 100 billion, with a B, billion stars in our galaxy, in our one galaxy, 100 billion stars. What's really neat about where we live is we're between spiral arms. This is important because where you have lots of stars, you have lots of radiation. I mean, we got one star pretty close by, just the right distance actually, to allow for liquid water and right temperature, but you don't want a whole bunch of these stars, okay? Sometimes you watch Star Wars, you watch one of these movies, and it's like, wow, there's 3 suns or something, and it's like, okay, that would be trouble. That's a lot more radiation, right? And so we have, we're between those. We're also not too close to the center. In here, there's lots of supergiant stars and supernova. A supernova is when a star explodes, and you don't want to be next to a star when it explodes, okay? You also don't want to be too far out in your galaxy either. You think, oh, then why aren't we out here? Well, there's not a lot of heavy elements in the outer regions of the galaxy. So chemistry class would be like a blast. It'd be like, kids, get out your periodic table, hydrogen, done, right? It'd be great. The problem is we're made of stuff that like we need. Like, we need oxygen, we need carbon, we need these other elements. So we seem to be in just the right region. It's almost like a Goldilocks zone, okay? Now, I can see that you guys are impressed by that. Say, Tim, I'm not impressed by that either. You're not going to play along anymore. Here's the thing. I want you to forget everything I just told you. You're thinking, already done, right? I don't know what you're talking about. The real fine-tuning actually is not to do with the Earth or the solar system or the galaxy. It has to do with the structure of the universe, okay? That's the real fine-tuning. This is the fine-tuning that's like got a lot of people wondering if there's a God out there who designed this whole thing, okay? So I want you to imagine there's a room in the universe, okay, that controls everything. Let's just call it the universe control room, okay? And in that room, you have these dials, and each dial is set to a certain position, and if you change the dials, you end up changing the universe as a result. Now, here's the take-home message. Don't touch the dials, okay? That's the rule. Now, because where they are set, for whether it's like the mass of the proton or the force of gravity or the speed of light, whatever it happens to be, we know or we think these are not like necessary. Like you could technically, in theory, have a different speed of light or a different gravitational constant. I mean, in theory, that works, but you end up changing the universe when you do that. And what happens is, when you do that, you go from a universe that will permit life to a universe that will not allow for life, a universe that prohibits life, okay? It's kind of like, remember back in the day when you had to like tune a radio? Who remembers those days, remember? Where you weren't like on Spotify or, Apple Music or whatever. Like you had to, oh, there's my station, don't go too far kind of thing, right? This is the analogy. When people say fine tuning, they're thinking about this. Here's a range of values, say your radio. And as you tune it, you got all this different space, but only certain locations will give you the station you want to listen to, right? In a similar way, there's like a range of values for the speed of light or the gravitational constant or the mass of the proton or the mass of the electron or whatever. But only a narrow position on this thing will allow for life, okay? Here's what some of the scientists are saying, and these are not Christian scientists. Here is Freeman Dyson. Now, he did not invent the vacuum, okay? That's a different Dyson. This is the theoretical physicist. He says, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe, in some sense, must have known that we were coming. That's interesting, right? Okay, here's Fred Hoyle. Fred Hoyle's interesting. He fought hard against the evidence for the origin of the universe. He actually came up with his own theory called the steady state theory to try to account for a universe that's eternal. He did not like the idea of a beginning to the universe. But he also studied the fine-tuning, and here's what he says about it. He says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics. I don't know how the monkeys always get into these discussions. And then he says, as well as with chemistry and biology, and there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seems to be so overwhelming as to put this conclusion almost beyond question. Here's one more quote. George Greenstein, he says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather, he puts a capital A, agency must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? The answer is yes. He says, was it God? Yes. Was it God who stepped in and so providentially crafted the cosmos for our benefit? The answer is, yeah. Okay, so what are these guys talking about? Why are they saying things like this? Here's why. And to understand this, we're going to do what's called theoretical physics, okay? Now, that sounds complicated. So let's talk about baking for a second, okay? We're going to bake a cake. But we're not actually going to bake the cake. We're going to do some theoretical baking, okay? Like we're going to take a recipe, and what we're going to do, instead of actually doing the baking, we're going to like change the ingredients and see what happens to the cake, okay? And again, we're going to do this in theory because, well, to make the parallel work. So like you could take ingredients, and let's say we doubled the flour, but just the flour. Okay, that's going to mess your cake up a little bit, right? You could like take the eggs out. Well, what's going to happen to our cake if we get rid of the eggs? You know, we could play that game. We could take the temperature from 350 to 800, and then we don't have to guess. Like we know what's going to happen to the cake, right? So we're going to do some theoretical, not baking, but physics. We're going to take the recipe of the universe, the constants, the quantities, the conditions. We're going to change them, put them into our equations, and see what happens. And what we find is big trouble. Let me give you a couple examples, okay? The first is the mass of the particles. Now, people used to think that the most fundamental particle was the atom, okay? The atom. That's the most fundamental particle. But then they started smashing atoms together, and they found out there's subatomic particles. And those subatomic particles are called the electron, the neutron, and the proton. And from that, trigger warning, periodic table. There's your elements right there. And from the proton, the neutron, and the electron, you can get everything you see on there. So you want helium? Here's how you make it. 2 protons, 2 neutrons, 2 electrons. Boom, you have a helium atom. Okay. Now I'm going to blow your mind because this was not the end of the story. They actually, in these particle accelerators, these colliders, have been smashing particles together, and they've actually broken apart neutrons and protons into what we call quark particles, okay? Now, I realize when you woke up this morning, Saturday morning, you do not think, man, I wonder if we're going to learn about quark particles, right? No. But inside a neutron and a proton are quark particles. And they don't have very clever names. The 1 up quark and 2 down quarks makes a neutron. 2 up quarks and a down quark make a proton. And they cannot seem to break apart an electron, okay? Electrons seem to be like, that's it. You know, that's fundamental. Now, here's what you need to know. These particles, the up quark, the down quark, and the electron, are like responsible for everything made of matter in the universe. And they each have a mass, okay? And that mass is ridiculously small. Now, I'm going to use kilograms because the whole world uses the metric system, okay? I'm just saying, what is with you guys? Gotta have you so unique, gotta be so like, we're gonna do our own thing. Okay, now these are very small numbers. These were not measured with your bathroom scale, okay? In fact, the way you get these calculations, you have to use E equals mc squared and some really cool stuff, but just here's the mass. Now, you did not wake up this morning thinking about these masses, but I'm telling you what, you wouldn't have woken up this morning if those masses were not what they are. In fact, there are some physicists who have played with the numbers. Not in real life, because you don't want to actually destroy the universe. We can't do that. So let's just see what happens when we play with the numbers with our computer modeling and so forth. If you were to increase the mass of the up quark by a factor of 3, so change it from that to that, okay, that's a very minor change, just a factor of 3. What happens to the universe? And here's what happens to the universe. You go from your periodic table to just a hydrogen-only universe. Like the entire, like think of every planet, every star, every galaxy. It's all gone. You have hydrogen atoms floating around the universe. That is a lifeless universe. That's a lifeless universe, at least physical life. What if we change the mass of the up quark by a factor of 6? Okay, let me show you this. I gotta skip this slide there. That periodic table, it's even worse because the whole thing's gone. And all you're left with is neutrons floating around the universe that never collide with each other, okay? Just neutrons, that's it. That's a lifeless universe. And if we were to increase the mass of the electron by just 2.5, again, a very small change, you're back to a neutron-only universe. So when these guys say it's almost like, man, when I study the details of the universe, like its architecture, it's like the universe knew we were coming. Why? Because it's like the fine-tuning is incomprehensible. Let me give you, okay, that was the mass. So that was the mass of the electron, proton, the up quark, down quark, and electron. Let me give you a constant in nature. So there's these constants in nature that were determined at the creation of the universe, and they haven't changed since. And here's one of the constants. I mean, that's why they call them constants, right? The gravitational constant. Now, the reason I can talk about this one is because we all know what gravity is. It's what's holding us in our seats right now, right? Every two objects in the universe are attracted to each other. Every two objects. I'm attracted to the earth, that's why I'm not floating away. But I'm attracted to this table. And we could do the math on this, okay? It's a weak attraction. I'm not getting pulled in because it's not very massive and I'm not very massive and the distance between us and so on. But I'm attracted to the Andromeda galaxy 2.5 million light years away, okay? In fact, I use this as a pickup line on my wife in university. Do you guys want to hear about that? Yeah. So someone asked, is your wife into science? And what's crazy is I met my wife at York University in Toronto, secular university. And I was studying physics, and she was studying chemistry, and there was chemistry. But we're both studying in the science library, it's called the Stacy Library. My wife's name is Stacy. And I went up to her, we got introduced to each other, and I was a bit of an idiot, and I had hair back then. It was a different thing. And I said, you're attracted to me. And she said, excuse me. And I said, well, gravitationally, right? It's a physical, and she married me. So single guys, take note. Now, the odds of getting a gravitational constant that will allow for life is 1 part in 10 to the 40th power. That's all the zeros, okay? Just so you get a sense of this number, the odds of you being struck by lightning are 1 in a million. That's the orange. The odds of you winning the lottery in Canada are 1 in 100 million. That's the orange. The odds of you being struck by lightning, surviving, and then being struck by lightning again in your lifetime are 1 in a trillion. That's the orange. The odds of you getting a life-permitting gravitational constant is all the zeros, okay? So I already did the dime thing. You guys heard that this morning. And so we can just kind of skip through this. But that would be like pulling that red dime out of all the dimes, okay, on a billion continents, all right? So that gives you a sense of what that looks like. Now, the gravitational constant is just one pretty easy to understand constant. There's a whole bunch of others. One of them is called the cosmological constant. This is the constant. Think about this. If every two objects in the universe are attracted to each other, why isn't our universe collapsing? Why is it expanding and not contracting? Because it would seem like even if the Andromeda galaxy is way, way out there, eventually, because we're attracted to each other, there is something fighting gravity. And that thing fighting gravity is a little bit unknown. They call it right now dark energy. Dark energy. It's the energy of the vacuum of space. And it is like a reverse gravity. It's like blowing everything apart, and that's why the universe is expanding. What's driving that is a constant, just like the gravity thing is gravitational constant. The dark energy that's blowing everything apart actually has a value of, is fine-tuned to 1 part in 10 to the 120th power. These numbers are incomprehensible. We think there's 10 to the 80th power of particles in the entire universe. That's all the orange. So we're talking about something that is again, imagine I put all the particles in the universe in a jar painted them all blue, and then one red. And then we like pulled the red one out, blindfolded. That's 1 to 10 to the 80. This is 10 to the 120. Again, these numbers are not comprehensible. That's why people are saying, man, it's like a super intellect has monkeyed with physics. It's like there's an agency out there, like capital A agency, who made all this stuff. Robert Jastrow, he was an agnostic astronomer, and he wrote a book called God and the Astronomers. And he was fascinated by so many people rejecting God in astronomy. And actually, like, there was a real, like they did not want there to be a beginning because of a beginner, and he saw all this stuff. Here's how he ends his book, though. He says this: for the scientist who has lived by his power, his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak, and as he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Because what have theologians been saying for centuries? In the beginning, God created the heavens and the earth. And this is where 20th and 21st century science is pointing to. And it's, again, this is not a God of the gaps. This is like what we know about fine-tuning, we did not know about 70 years ago, okay? Some of this is I mean, just a few decades old. In fact, I just want to encourage you, if you're into this stuff, there is a book that will blow your mind called A Fortunate Universe. It's written by, it's awesome. It's written by 2 Australian astrophysicists. One's a Christian, one's an atheist. And they both agree the universe is fine-tuned. And so it's called A Fortunate Universe, published by Cambridge University Press. And it's kind of fun to read because they're Australians and they kind of joke around a little bit. And they're colleagues, these 2 guys, Luke Barnes and I forget the other guy's name. And what's fascinating is 7 or 8 chapters, they argue fine-tuning. Like the stuff on the up cork, down cork, they get into all that. And then then where they differ is how to explain the fine-tuning. And what you get from the Christian, Luke Barnes, is I believe that this is God is the best explanation. And then from the atheist, Geraint Lewis, he says multiverse explains this. There's a multiverse. And then they respond to each other and respond to people who say there was no fine-tuning. They say, are you kidding me? Like read the literature. So A Fortunate Universe is really eye-opening on all this stuff. I'll just kind of close here and then we'll take some questions, but it's fascinating to me that the God who made everything we looked at and all this like fine-tuning, he didn't this is not like a deist God, okay, who's detached and distant. Like we had a hamster during COVID. We got him, it was like $12 or something. The cage cost more than the hamster. Right? And my kids, we wanted all this like wheel and the tunnels and stuff. And it was a cool little thing for our hamster. This isn't like that. God didn't just make a cool cage for humanity. We know that in the beginning was the Word was with God, the Word was God. Verse 3, fascinating, all things were made through him, and without him was not anything made that was made. So the Word is also the creator. By the way, if you're talking to Jehovah's Witnesses, it's a great verse to go to, right? Everything that was made through him, the Word. And Jesus can't be one of the made things. If he's one of the made things, then he would have had to make himself. No, everything that was made through Jesus. Jesus couldn't make himself, so therefore he must be God. And then finally, verse 14 jumps down. It says, and the Word became flesh and dwelt among us. So the God who made everything we just looked at actually became one of us and dwelt among us and in fact died for us. Really incredible, really incredible. I'll leave you with these words from hymn writer Isaac Watts, who, by the way, he said that it was, what's his name? Charles Wesley, who wrote a bunch of hymns, Charles Wesley said he would have traded all of his hymns if he could have wrote this one, okay? And Isaac Watts, When I Survey the Wondrous Cross, says, we're the whole realm of nature mine, that were a present far too small. Love so amazing, so divine, demands my soul, my life, my all. Our universe is incredible. We don't know how big it is, to be honest. In our best technology, to go from one star, like our sun, to another star, like average distance, going 5 miles a second, in our best technology, a space shuttle, it would take 200,000 years. One star to another star. That's why I kind of laugh when people talk about aliens and this kind of thing, like little green men flying around. When you understand the physics involved, it becomes pretty ridiculous to think. Where'd they come from? Because in our best technology, it takes 200,000 years to get from one star to another star. And that can make you feel real small. It can make you feel really small and insignificant. But what's interesting is, not only, people ask, why is the universe so big? The heavens declare the glory of God, so they're going to be big, okay? Because why? Because his glory is awesome, right? But also, David, who wrote the heavens declare the glory of God, also said, when I consider your heavens, the work of your hands, the sun and the moon, which you have set in place, what is man that you are mindful of him, the son of man, you care for him? It's a rhetorical kind of question because he answers it. He says, yet you made him a little lower than the heavenly beings and crowned him with glory and honor. So you have, who am I when I look at the heavens? I am nothing. I am insignificant. I'm small. But I'm also made by you. So that gives me significance. I'm made in the image of God. So now I have that significance because he's mindful because we're made. We have a maker. And so we're the whole realm of nature. It'd be far too small. What do we give? What could we possibly give to a God who made everything we looked at? And the answer is, you don't really have any. You can't just say, here, look what I made, you know? No, what he wants is our lives. Pick up your cross, right? Deny yourself, follow me. That's what he wants. All right, we got 12 minutes, something like that. So I'm going to take all your questions, and then we're going to let you guys go. Who's first? Yeah.
So do you have an opinion on like the whole climate change thing when it comes to this?
Yeah, I do. I think that there is again, it always depends on what you mean by terms. So at Stand to Reason, we always talk about, what do you mean by that? So when you said, what's your opinion of climate change? I would want to ask, what do you mean by that? I think the climate is changing, for sure. You know, it changes. I mean, this is part of everyone knows, there's no debate whether the climate's changing.
We're not going to burn up.
No, that's right. So that leads to the second question. How much, by the way, is man-made? That's another question. How much is just part of the cycle of how the universe works, how our solar system works, how the earth works? Like this year was a really warm winter, you know? We didn't get a lot of snow in Toronto. So it was weird. We were talking about this out there, actually. I mean, this is the 1 year. Our kids learned to ski last year, and we bought like season's passes for skiing. It's like, where's the snow? But there are other years where it's like minus 30, you know, for weeks. So I think there is a natural kind of cyclical thing that happens. And just depending on, you know, even things like solar flares and you name it. I have no concern about burning up or whatever. Like, give me a break. This is some of this stuff is just propaganda, like 2 weeks to flatten the curve. You remember that? And I mean, go watch An Inconvenient Truth with, what's his face? Al Gore. All the stuff that he prophesied, you know, it was like, man, if we don't fix this, New York's going to be underwater. Okay, how's that working out? Last time I was there last year, it seemed fine to me. You know what I'm saying? Like, but he had predicted by a certain time, and that time has come and gone. So a lot of this, like, honestly, it sounds to me, it's like the secular version of predicting the end times. That's what it sounds like to me. It's like, you watch these guys on TV, hey, look at the blood moons, look at the whatever, and, and then they predict the time, and here we are the next day, still here. Jesus didn't know the day or the hour. In the same way, these guys, there's a lot of like, if we don't do X, Y, and Z, the world population, the this, the that, and the polar bears and everything else. And it's like, well, those times come and go. I'm not saying we shouldn't be concerned. We should be good stewards of the earth. There's a middle ground here where we ought to be concerned about the world. And certainly we're to have dominion over the earth. This was the first kind of mandate. And part of that is, I think, being good stewards of the earth. So, but I think there's a lot of nonsense out there as far as, when people start throwing around global warming and all this other stuff. But they'll spend billions of dollars on it like crazy. I mean, come to Canada, see what they're doing. All right, anyone else? Yes.
Got an easy one for you.
Oh, yeah.
So, back to evil.
Yeah.
If our arguments are evil exists because of our rejection
Yeah. Yeah.
and of our free choice, what do you do with God's sovereignty, including determinism?
Yeah. Well, I'll just be honest with you. I'm not like a theological determinist. I work with some. And so I think, I think God's sovereign over the whole process. It didn't catch God. I'm not an open theist. I don't think God was caught by surprise what Adam and Eve did. He knew. And I would even go and say he like this thing was planned. Now, how does that all kind of work out? There are some mysteries that you preface this by saying it's an easy one. Just, your classic sovereignty, moral responsibility, freedom. And again, all those terms we'd have to define all of them, right? What do we mean by God's sovereignty? He's the ruler of this world, no doubt. And then determinism, what are we talking about there? Even freedom. I think everyone holds to some kind of freedom, whether that's a compatibilist freedom or a libertarian freedom or whatever. So I think the determinist has his own set of problems, questions. Let's call them questions. If God is theologically determined everything, then you have a mystery when you get to Adam and Eve's sin. Because I know R.C. Sproul, he didn't want to go there. He kind of just punted that one. But his son didn't. His son was willing to say, in what I read from him, that no, even the first sin was determined by God. Whereas R.C. Sproul, who has a strong view of sovereignty and so on, basically, said, no, I'm not gonna say that, and I'm just gonna appeal to some kind of mystery behind this. Fair enough. I mean, I think you have to somewhere along the way, because there are some things here that just seem to like rub in different directions. You have verses and that talk about strong. It seems to be an appeal to freedom. Choose this day who you will serve. These kinds of like appeals that make it sound like there's a genuine freedom going on here. And then you got this other thing where God's coming in basically saying, no, this was determined before you were born. How do you make sense of that? So I think this is actually not a negative to Christianity. I think having different kinds of responses is actually like a diversity of views within orthodoxy actually serves as a positive when answering very difficult questions like this. Because what we can do is we can say, look, there's some different ways that we can approach the evil in the world. And if this doesn't work, well, we also have B, C, and D. You know what I'm saying? And so I think that having that diversity when it comes to these questions, like secondary kinds of questions, certainly I'm not appealing to that when it comes to essential. Talk about the resurrection. Physical bodily resurrection, yeah, that's it. It's not A, B, C, and D. It's not like, you could also believe in a spiritual resurrection or something. No, that's off the table. But when it comes within the frame of orthodoxy, I think that answering this question, we got options. So I was talking to Amy Hall, who works at Stand to Reason, who is a strong, she might even call herself a determinist. And I asked her, what do you think about people who appeal to freedom? Because she doesn't like the free will defense, which I offered a kind of version of the free will defense. And she's like, I got no problem with it. I think you're wrong. But this is, I think, if Amy's wrong, if she's wrong, then this is a viable option, right? And I think that's a kind of a wise, kind of charitable approach in dealing with especially difficult questions like this. So again, I can't answer. There's so many questions I have personally about all this stuff. But what I want to do is offer up insights. And so I think I called them. Here's some insights. And, you may not like that evil's a privation. You may be like, nah, I think evil's a substance, a thing, just like goodness. In which case, yeah, then that whole Augustine approach to responding, or, Aquinas talked like that too, that's not going to resonate with you. Fair enough. I'm not going to lose sleep over that. But my hope is that you can sleep knowing that there is evil in the world and God is still good, and how we make sense of that could look different for different people. It's a good question. Any more easy questions? Yeah.
Again, not easy, no definitive answer for it. I just see the progressive Christian movement as
Yeah.
evil and detrimental to Christianity than anything, because it's calling itself.
Yeah, Christianity, yeah.
Worse than even atheism, because they're, we're
Yeah.
you're not.
Yeah.
I'm just not sure how to deal with it.
I think you're right about that. I don't want to cut you off, but I think you're right about that, that it is more insidious because it's claiming to follow Jesus. It's claiming to these things. At least when I talk to my atheist friends, they're willing to say, look, I'm not pretending to be in your camp. I'm like, they know they're outside. They're the world.
Right.
These guys are wolves. And the wolves in sheep's clothing that's where things get tricky, right? Is trying to navigate that. So I think you're right about that.
Even talking to someone to bring them to Christianity, if they see that as what Christianity is, then you're trying to explain it.
Yeah. This is why understanding basic Christianity is so important. I think, is it John Stott who has, a little book called like Basic Christianity or something like that. There's others like that we as a church need to do I think we do a decent job of this, but just keep being better at it, communicating what the real thing looks like. Because when you understand the real thing, you can spot a counterfeit from a mile away. It's people who don't know what the real thing is that get misled by counterfeits, right? So that's going to be, I think, an antidote to the progressive movement. I think that a lot of people, especially young people, are sucked into the progressive movement because it talks about inclusivity and tolerance and all these other things that are kind of like the buzzwords that they're hearing all over the place, Hollywood and wherever, and a piece of this is that they were raised in churches like I was. I love my church. The people were beautiful. I just can't say enough. In our book, we talk about, I really had no bad church experience. I mean, there was some things, but I knew the real from the fake. I mean, I guess I could say there wasn't any. Our pastor, now I was a teenager at this point, but our pastor cheated on his wife. This was devastating. But I knew that, what he was doing in his life did not represent Jesus or his church. So I guess what I'm saying is we have people raised in the church, going to Sunday school, doing the youth events, all the stuff, because I did it all. But I did not understand what Orthodox Christianity was until I was in my early 20s and started looking into this stuff. I was, if you had asked me, what is the gospel? I don't think I would have given a coherent, or it would have been very simplistic, like very, very simplistic. And so that, in my own mind, when I think about, okay, when did you become a believer? You know what I'm saying? It's hard when you're raised in the church because you're just like given beliefs. Here you go. Here, believe this. Here, believe this. You accept beliefs like you accept Christmas presents. Sure, I'll take that. And then you get out in the world and you get challenged and people start talking about how bigoted your views are. And you're like, I don't want to be a bigot. Okay. And so, but you don't know any better, right? Because you don't truly know what is the biblical view of love. What is the biblical view of X, Y, and Z? So, I would want to encourage us to let's get our Bibles open and let's start teaching what's actually in the scriptures, so that when they come up against the world saying something and it doesn't line up with this, I can say, no, that ain't right. But if I never open this thing, I will never know. And I just hear someone say something like, Jesus said, love your neighbor. Well, I guess he did say that. Okay, so I guess, and this is what I think people are being pulled away, or whatever you want to call it, falling away, as Jesus used the word, or having their ears tickled or whatever, because they don't have any defense against it. Yeah.
For a person that is non-Christian or quasi-Christian,
Yeah.
that asks the question, how can you believe in God
Yeah.
if you believe in science?
Yeah.
I have an answer for that.
Yeah.
What is the best book that you would recommend
Oh, yeah.
for a non-science person
Oh,
to explain some of what you talked about?
yeah. For a non-science person, that's a good question. I really like, if you've ever watched a lecture from John Lennox. I find John Lennox, I quoted him once or twice. I think that he's a great communicator and uses a lot of analogies, and he's easy to listen to, even for people who are not science oriented. He's got a book called Cosmic Chemistry. Cosmic Chemistry. It's a new title. It's an updated version of God's Undertaker. That may be a really good book. He kind of goes through, here's one chapter on origin of life, one chapter on science and faith, one chapter on fine-tuning, one chapter on origin of the universe. And so you get one chapter on miracles, are miracles even possible? Is that a thing that can happen? That would be a really helpful resource. And again, not too long. I'm thinking of, you guys have Signature in the Cell. Stephen Meyer is amazing. The problem with Stephen Meyer is all his books are this thick. What he needs to do is all those books need to be an abridged version that is because he actually can write really well to the normal person. But what he needs to do is write all those books, but make them 180 pages that you could give to somebody. Unfortunately, there isn't a ton of those kind of books out there. Or if they're out there, they're written by Francis Collins, who's a theistic evolutionist. I wouldn't recommend that book. Yeah. Let me think about that more. Nothing's jumping out at the moment. I mean, they got whether you're young Earth, so you guys have the Ken Ham stuff, the Answer in Genesis. There's some good stuff there, but dealing directly with what I'm talking about, I'm trying to think. I think probably broad picture, you have John Lennox would be a great, resource. But if you're just starting out, I mean, the stuff that you got in your library would probably work as well.
Why don't you write Sean's outline to those longer, better texts?
Yeah, my publisher wants me to write that book. I said, forget it. What I want to do, my next book project, I'm hoping will be a red pen book, and it will be almost like a critical thinking activity book where it comes with a red pen. Here's the steps, and there's a whole process that I would go through before I ever read pen. Here's how it works. And it would come with actually little videos. So there's an intro, like a QR code, watch the YouTube, and then at the end, you can check your answer with my response. So I don't think people can think critically anymore. And that's partly because no one's teaching anyone to think critically, at least certainly not in the public system. There's some of that happening in homeschooling, classical education, but very little critical thinking is happening. And I went through the public system. I didn't know what a logical fallacy was until I was in a philosophy class in university, like doing my master's degree. So so that's where I really I think it's necessary, but I also think a book on like a practical for the everyday person on science and faith would be a good book too. Yeah.
I was just wondering if Red Pen with Mr. B is sort of like Mystery Science Theater.
What is Mystery Science Theater? Is that like...
There's a guy that's sitting in a darkened theater watching a movie and he's commenting the whole time and making fun of them.
Oh, yeah.
Is it kind of like that?
Have you not seen Red Pen Logic?
No.
I'm offended.
No.
It's kind of like... you'll have to watch it afterwards. But I just kind of sit there. I think here's why it's... By the way, I think here's like the secret sauce, okay? If you want to do well on YouTube, so my videos were 3 minutes when they started, okay? I try to stick with that. I play 1 minute video that starts the thing where it's the TikTok. And usually it's a TikTok that's gone viral already. So I'm showing a viral video, and then I just am waiting for them to finish. So people they watch my video because they're listening to the original video, and then they want to hear me say something. And so when I start talking, I've now held you for 33% of the total video length, which in social media analytics, that is a home run. Because most people die, or they're gone. They're like, click, moved on in 5 seconds. So that's part of it. And then if they hang on and hear me for 2, then I'm now responding to at least 1 or 2 things of what they've said. So anyway, that's what it is. It's kind of like, it's not like making fun. It's not like, it's very stick to the ideas, not the individual.
You're the logical response.
That's right.
Okay.
Yeah. So it's not like, Ben Shapiro versus, or Matt Walsh versus, a lot of people want to see that. They want to see somebody dunk on that view or own the person or, all the words that get used. What we try to do is a little more of an ambassador approach. It's like, okay, I'm going to, as Colossians 4, 5, and 6 says, I'm going to walk in wisdom towards outsiders, making the best use of my time. Let my speech always be gracious, seasoned with salt, so I might know how I ought to answer each person. And that's my goal, is I'm going to kind of sprinkle it with a bit of salt on there in my response and tactically respond. So, and by the way, as a Canadian, I do not feel comfortable ever doing this. Like, it's so not my nature to have this showdown, between people. And I don't like the conflict. It stresses me out, all this stuff, but it needs to be done. Someone needs to say something. So anyways, that's what it's all about. Yeah.
Similar question about a book for a guy who's probably not going to read through the Bible, but the guy said he's not sure he believes in God,
Okay.
but he does believe that Jesus existed because that's history.
Yeah.
He was a history major.
Yeah.
What would you recommend on the historical end?
Oh, wow. I think he just needs to keep going down that road, because you have, if he cares about history and Jesus is a historical figure, absolutely, there's no doubt. But it's just not that he's a historical figure. It's those resources, the Gospels, Matthew, Mark, Luke, and John are historical documents. So there's some decent books on this. Kind of a fun book for someone to read would be J. Warner Wallace's Cold Case Christianity. And that dude is so sharp. I don't know if you've heard of J. Warner Wallace. I think you sell his book out there. He's a cold case homicide detective. He's been on Dateline more than any other detective. He actually has solved murders that were committed 30 years ago, when they have no eyewitnesses left. How are they doing this? How are they putting these people behind bars and catching them? It's using forensic skills. And what he does is he applies those forensic skills, that analysis, to the Gospels. And what he finds is, by the way, he became a Christian through this process. As an atheist detective, becoming a Christian because he was like, the Gospels are legit. And by the way, it all started for him because he went to church. His wife kind of dragged him to church one day. She started going. And he's like, well, I don't want to be a part of that. But he went, and the pastor said Jesus is like the most important figure of history. And he's like, I want to investigate that. So it all started with just a very minimal view of Jesus. Not that he's God, not the resurrection, none of that stuff. It was just this claim that Jesus existed, and was important. And then that book is just an updated version, year or something. It's awesome, and so he'll like that. Yeah.
He also wrote one for kids too, which I
Yeah.
like better because it's easy to read and it's short.
Yeah, all his books are, he's got Cold Case Christianity, God's Crime Scene, Forensic Faith, the guy's a book writing machine, Person of Interest, which is about how Jesus changed the world, art, music, science, you name it. And he's working on one right now about human nature called The Truth About True Crimes. And it's all about biblical anthropology and how a homicide detective, I don't know. Everything has to do with detectives and homicides and everything. So, but all those are in kids' version as well. My kids have read them. They love them. They love Jay Warner. Anybody else? Good questions. And you guys got a cool library out there. I would follow up. Actually, I was going to mention, we talked about this. Neil Shenvi has a book. You guys are selling it called, what's it called? Why Believe. Why Believe. And Neil Shenvi is a very smart thinker, very clear thinker. I actually haven't read the book, and it's on my list. I almost finished a book on my way here with my flight, and then it's an audio book on God's existence. That was I wouldn't recommend, but it was pretty good. Yeah.
Where do you find good audiobooks?
Yeah.
Audible or...
So Audible is a good place to go if you already know kind of what you're after. What I actually been using is an app called Hoopla. Have you guys heard of Hoopla? It's connected to my local library, so I don't pay for any of these books. I just go on there, type the title or the author, and see what they have. It's more limited, but that's my first place because I know I'm going to get it free from my library. And then if they don't have it, I might have to buy it. So Hoopla, Hoopla. It's an easy app. You just connect it with your library card number or whatever, And it's a great little app. And by the way, if you call your librarian and say, hey, I want this book, they may get it for you, and then you can download it through Hoopla. So, yeah. Because I'm typically a library. If you recommend a book, they grab it for you. They'll pick it up. So, if you want to get a book at your local library, make sure it's The Deconstruction of Christianity by Alisa Childers and Tim Barnett. That'd be a good one to get in the library. I don't think it's on Hoopla yet, at least not on mine. I just want to plug also Tactics. I know for me, a game-changing book for when I was doing apologetics. I mentioned in university being challenged about what I believe. This was second year university, and starting to actually investigate my faith for really the first time, and going deep and discovering Richard Dawkins and others, and also discovering there was smart Christians out there too. I couldn't believe it, Never heard of any of these guys. And it was through kind of that journey I discovered Stand to Reason, which is the ministry I now work for, which is just crazy to me that I was listening to their podcast, reading Tactics, that book that's out there by Greg Koukl is the best book for conversations with unbelievers. His new one is called Street Smarts. And it's the same idea. It's tactics, but so if you just want to get the latest one, it's called Street Smarts. It's on Hoopla, I think. Tactics is, again, so good. I use that in my engagements more than, those skills more than probably any other skill. Obviously, if you're talking Bible, hermeneutics would be a skill. Okay, so yeah, you got to know that. But if I'm just kind of having a conversation, those questions to ask and this kind of thing, that's all from the Tactics book. Yeah. Yeah.
I just looked on our Hoopla. Your book is on there. It's an ebook.
Boom. There you go. That's pretty cool. So someone in this area, was it you? Did you call the library? There you go. Okay. I know it's after. I want to be respectful of your time, and I got a long drive ahead of me to Chicago. So I'm going to pray for you guys, and then we'll dismiss. Father, we're grateful for this time where we could spend together, just digging into some really tough, challenging questions, stretching our minds. Thank you for how you've equipped this church. Thank you for their willingness to go deep and plan an event like this on some really important issues. God, I pray that this would bear a lot of fruit, that those in this room would take what we've learned today and apply it to their lives in really practical ways, that we would see people come into your kingdom because of the dedication, the devotion of spending 6 hours together on a Saturday, just immersing ourselves in some of this material. So God, I pray that your Holy Spirit would kind of carry the ball to the next level, that we would create those divine appointments, that there would be opportunity to get into those conversations, and that we would bear fruit that remains. Thank you again for this time. Pray a blessing over everyone in this room. In your name we pray. Amen. All right. Thanks, guys.